Okay, let's try this again. This time we're talking about a project from about 2 years ago. It's a couple little projects. So this is triboelectric nano generators, or other words called tangs. The concept here is you take two triboelectric materials that are far apart from each other on the triboelectric scale, such as aluminum and Scotch tape, Scotch packaging tape, right? And so this is HVAC tape here, HVAC aluminum. Also works with normal household aluminum. You can look up the triboelectric scale if you like, but I started out replicating some small ones from people, and the whole point is you want two aluminum leads, and then you want to cover one. Well, let's say you had two strips of aluminum. Cover one of them completely with Scotch tape, and that's it. And then have the end of both of those open so you can get to the aluminum. And then if you touch one to the other and pull it apart, it generates a voltage. That's AC. Okay, so I mean that's essentially static electricity. So here you see I made a book that is like six pages or something first, because I was playing around with it. And then this goes to a rectifier, so this converts AC to DC. Alright, it takes any positive or negative signal. And then if I squeeze the book just a little bit, just move it, I'm just moving it a tiny little bit, is lighten that up. This is all I'm doing. Okay, so I was trying to get a lot of surface area. Yeah, the more surface area you have, the easier it is to light, and the more power you can generate. Although I'll tell you what, the power curve goes up kind of weird. It's basically like the voltage goes up way before the current goes up. So you kind of want more of a whole bunch of these in parallel, I would think, for more power. But I always say that, and then I think I tried to do that, and I don't think it worked very well. I don't remember. I got sick of these things. But anyway, here's another one. So this actually has, I tried to do, I was using HVAC tape, like I said, like a roll, and Scotch tape. And I tried to come up with a design that would be easier to put together. So this is actually one continuous roll of a spiral, and what I did was somehow I combined it so that it would be one single piece that I could then roll up, and then as I squished it, it would make the, I guess this side's covered with Scotch tape. I guess so the inside of that, the other side must have aluminum on it, and it must be two leads separated by the insulator, which is probably the paper. So somehow I figured out some way to do that where I just used the tape, so it was more efficient. So I could just do a whole lot at once, big length, roll it up in a spiral, and then you squeeze it, and wow, it lights up really easy. And it's a nice little compact, infinite flashlight that will never go bad. And all you have to do is squeeze it. Is it that bright? Not really. But in the dark, there you go. But this is also kind of, it's kind of big. Oh, by the way, what you're actually kind of doing is you are compressing and decompressing a capacitor. It's actually like it acts like a variable capacitor. So because it's really just two electrodes separated by an insulator, and then they are getting closer and further apart. That's another way to explain these things. Next one I did was this, which has, I put some neodymium magnets on one side so that they're repelling. And then I had some 10 microfarad capacitors in between a set of LEDs that were in series. So it would be like LED and then capacitor, LED, capacitor. And it gets all the way to the end there. And then there's a resistor, which I'm guessing I used like just a 1 ohm resistor. I don't remember. But the point was to slow down the drain from the capacitors. So the whole point of this was to have more of a persistence of vision LED that stays on for a period of time, so that you don't have to constantly be doing this to get a light, right? And this is easier to squeeze and unsqueeze because it's got those magnets in it. Next, this one is like, so these ones, this was like 6 volts, this was like 10. I think this got up to 15 or something. I made this has a whole lot more layers, and this was something around 25 volts, something like that. So I go out from the teng, I go to another rectifier, and then I have like 5 different color LEDs in series. So it's the sum total of all of those is high enough voltage. So it must be generating probably like 3 volts times 5, at least 15 volts. You'll see I can just kind of tap this and they light up. Still kind of got to push on it. And then I made this one. This one has a whole lot of layers. So I don't know how many are in here. I was trying to get a whole lot of surface area. So this has maybe like 200 layers of Scotch tape and aluminum tape. I use a Ziploc container. I use sponges. Probably not the best idea if they get wet or something, but you know, it held it together and it made it so I could separate the leads and then just use alligator clips on the sides on the 2 separate leads. Okay, and then I can close this up and I can shake it vertically like this, or I can, you know, like that. Again, this right now, this is coming out to a rectifier and then just into an LED, white LED. But you'll notice that it is a lot easier now to light this up. Well, if I can get it visible. Hold on, I have demo problems. Put it somewhere. It's hard working. It's really hard work on one hand. I have like a stand thing upstairs, but it's like holding my robot up right now. Okay, that kind of looks good. So, but the point here is, one, this lights up a lot brighter. It's a lot easier for this to accidentally just turn on. So a lot of times I just pick this thing up and it lights up the LED. Let's see if I can point it at the table while I'm doing it. Maybe you can see how bright it gets. So that's a lot brighter. I don't know, it's kind of hard to show. Anyway, this actually will do 50 volts. This is 50 volts. Is it a lot of current? No. But it's 50 volts. Spikes of 50 volts. Very instantaneous spikes. So that, you know, not necessarily good for your LED. Normally you want to limit those to you know, like 5 volts. But it does go up to 50 volts. Then I did one here where I combined solar panel with a teng inside of this box. that would charge up a capacitor that I could then adjust with a potentiometer. And I had one of the LEDs is attached to the teng before it goes into the capacitor. So anytime I'm charging the capacitor from the teng, this lights it up. But you know what? It's not a lot of power. So all in all, the majority of the power is actually would come from the solar panel, and the teng is pretty much useless. This one I tried to do more of a carry in your pocket. It's very slowly charge up a capacitor. I'm looking at the cap right now. It says it is 680 microfarads, okay, 16 volts. And I think I had that switch in there, and the whole point of this was you're carrying it in your backpack hiking or something, and it's charging up, and these magnets keep it from completely making contact. It has two of them in there. I guess I was trying to do it in parallel. And so you do this a lot while you're hiking, and then when you finally get to where you are, then you can open up your little emergency flashlight and hit a switch, and it'll light up the LED, which I don't even know if it'll light up now. Probably not. I can't tell. I don't think it's lighting up. I think it took a while to charge that way. There's not a lot of surface area in those folds. Next, we get on to some better designs. So I ended up kind of with, after all those things, these are the two best designs that I have. Alright, one of them is a little book that I bought. It's like a notebook from CVS, which is it's like a drugstore in the United States, for those of you not in the United States. And I actually just cut all the pages out, because I really just wanted like a case that I could squeeze. So chopped all these things out. I made my teng, which is about 10 folds of a teng. And then that goes into a rectifier again, and then into I think looks like a 10 microfarad capacitor that's rated at 50 volts for some reason, and then some kind of resistor. I can't really read that right now. Let's see, it's brown, yellow, black, blue, brown. Y'all can look it up. I don't remember what that was rated at, but anyway, that goes into a white LED. I suck at I think I can do 1 ohm resistors or something. You know, it depends on if I've worked on it in a while. Anyway, I can squeeze this, but you'll notice that it's a persistence of vision LED. And then based on that resistor value, I found this to be very useful. So this is a very good emergency flashlight that you can carry around, and it's bright enough to see in the dark in your tent. It has persistence of vision, so you can actually kind of use it to, I don't know, find your phone in your tent if you're in the woods and your flashlight's dead or something. Okay, so if I squeeze this, it will stay on for, I don't know, 30 minutes, something like that. You know, it's not that bright, but in the dark, you can see it now. It's a lot better than a lot of the demos I see people do. And the whole difference is you just have a whole lot of these folds. This one is not a persistence of vision, but instead of using a rectifier, you use just 2 LEDs, and you wire it so that they go in opposite directions on your electrodes, right? Because why do you need to rectify it when an LED is a diode? right? So you go from basically you have your two aluminum things. One of them's covered up with Scotch tape, and then you have one LED going from this aluminum thing to this aluminum thing, and then another one going from this aluminum thing to this aluminum thing in the other direction. That's all this is. So this is aluminum, Scotch tape, two LEDs. And then I can squeeze it a little bit, and it lights up, and it's really bright. And I can imagine, I can tap this thing and it lights up. Okay, so you can imagine wearing this thing on around your neck, in, I don't know, at a construction site in the dark or something like that, or maybe on the top of your construction helmet if you're working on the highway, and every time you take a step it blinks and it never runs out of batteries because it's got this triboelectric nano generator in it. I mean, I don't know, it'd be a nice safety device. It's not that bright. This stuff, this material on the top, I think that's just hot glue. I occasionally use Plastamake when I'm doing stuff. I think this is just hot glue. Yeah, it's just hot glue. I wanted to pull this apart to show you what I did. So there is no complicated circuitry in this one. It's really just tape, and it looks like I have, oh, but I got good at it. I was trying to do a really quality one here, and you'll see how symmetrical looking this is. So this is like 20 folds, and then I attached here with some copper alligator clip looking things with the flat things on this end, and then I hot glued it so that there'd always be pressure holding them in. It's really hard to solder to HVAC tape. There is a way to do it with olive oil or something. You put the olive oil on the tape first, and then you have to heat it up with a soldering iron. It sucks though. I mean, I tried it. So most of the time when I make these things, I will just figure out some other way of attaching the leads to any circuitry or the LEDs. Anyway, that's what I want to show you guys. So these two things here were what I ended up with in terms of practical uses after all this junk. I kind of like this one. It was nice, like at the form factor and the squishiness of it. You know, you kind of hold it in your hand. This one, I don't know. I feel like the movement's too. I wouldn't want to do this. But you know, this I could do. Just, you know, I don't know. I like the form factor of this and the book. And I tried this in a backpack to charge up a capacitor before, just so you know, and it's really not a lot of power. It's high voltage, low current. You get these spikes, and you can look up. There's a paper. Someone, I think it's University of Georgia, something like that. I think it was Georgia. They have a paper in there, and he has some other designs. You know, try to capture the full spike and make it continuous, and using flyback diodes and all this stuff. And I tried some of those circuits. I got sick of it. So anyway, this is what I like. I like this book. I like this book, this thing, and so energy harvesting. Success, probably not. This is kind of no power. So if you're going to do any kind of energy harvesting, like a solar panel, is infinitely better than these things. These could power, you know, like microcontrollers, like a tiny little Arduino trinket or something. So imagine you have this sitting on a buoy out in the water, and it's just bouncing up and down constantly, so you don't have to do any work. So it's just charging up a capacitor based on the wave movements, and then when that voltage gets high enough, well, it turns on your Arduino trinket with a you know, GPS detector and you know, some Iridium modem or something to tell you where the beacon is out in the ocean, you know. So there are some designs like that already. There's some people doing that, and you could be one too. So good luck, y'all, with your other triboelectric nano generators. And if you happen to find a design that's better or easier to combine than this, that'd be great. And please let me know. I have tried other materials, by the way. I tried some Teflon tape and Captain tape, and I don't know, PTFE Teflon tape. I don't know. I tried a couple different things, but so far this was the most accessible and cheap, and easy to throw together materials. So Home Depot for the HVAC tape, and it was called Nashua tape, and then Scotch packaging tape is what I used. I don't know if there's a different consistency for the packaging type versus the other type, but that's what I used, is Scotch packaging tape. Okay? Alright, y'all have a good day. Goodbye.